All right. So let's take a look at these two because we're doing a pretty good job for the most part with the first one. If we were working on it on Classkick itself. And then the second one was a little bit more of a struggle. So number one says the specific heat of ethanol is 2.46 joules per gram degree Celsius. Find the heat energy required to raise the temperature of 193 grams of ethanol from 19 degrees Celsius to 35 degrees Celsius. So first and foremost, we got to remember the equation we're going to use, especially when we hear the word specific heat. When we hear the word specific heat, we need to think of our Q equals MC delta T equation or Q equals MCAT equation, which means we have to figure out what we know from that equation and then what we're going to be looking for. So if we write out each of these variables, all right, let's identify what we were given based on our information. So that first sentence, that 2.46 joules per gram degree Celsius, is that our mass, our specific heat capacity, our change in temperature, or our heat energy? Which variable? MC, delta T, or Q? It's C. Awesome. This is our specific heat capacity, which means it's right here, 2.46 joules per gram degree Celsius is our specific heat capacity. All right. It says find the heat energy required to raise the temperature of 193 grams of ethanol. What is that 193 for? Is that the mass, the temperature, or the heat energy? Is it the M, the T, or the Q? Awesome. That's our M because it's in grams. So that's our mass. 193 grams. All right. So we have our mass. We have our specific heat. All right. And then it says we're raising it from 19 degrees Celsius to 35 degrees Celsius. So is that 19 to 35? Is that going to be our delta T or is that going to be our Q? Is that our temperature change or is that our heat energy? What do we think? Those temperatures or those energy? That's going to be our delta T. And the other thing I want us to remember is that delta T is really our final temperature. So our final temperature minus the initial temperature. All right. So it's always our final minus the initial. And it can be negative if we decrease in temperature. So we get colder. But in this case, we're getting warmer. So we're going from 19 to 35 degrees Celsius. So to find our delta T, we're going to take our 35 degrees Celsius minus our 19 degrees Celsius. So we do 35 minus 19. Let's just find that part right now. What's our 35 minus 19 going to be? $16. Awesome. So we have 16 degrees Celsius as our change in temperature, which means the unknown variable, the thing we're solving for is Q, which should be the case because it says find the heat energy, which means if we're finding heat energy, we're looking for Q, which means that we are on the right track. Which means now we can use our Q equals MC delta T equation. Let's plug in what we know. So Q equals M, which is 193 grams, times C, which is 2.46 joules per gram degree Celsius, times our delta T, which is 16 degrees Celsius. So now to solve, all we're going to do is multiply 193 times 2.46 times 16, and we should get a Q value. And what does Q equal? Anybody get a Q value for me? No, a couple people already had it. Awesome. 7,596.48. And that's the units of joules because our grams got canceled, our degrees Celsius got canceled. And then if we go to sig figs, sorry, that handwriting looks a little messy, but if we go to sig figs, if we look at our problem, our first number up here has 3, 3, 2, and 2. So what should we use for our significant figures? 2 or 3? Two. Awesome, awesome, which means we're going to have 7,600 joules. Remember, if we did need to put 3 and you wanted to keep it as joules, you can always put the bar above the number you want as your significant digits. But because those zeros don't count without a decimal point or a bar, we know that this is only 2 significant figures here. Any questions on this first one? All right, so number 2, the second question got a little bit harder, okay? And it was meant to be a little bit harder. And it says, what mass of 54 degrees Celsius gold must be added to 468 grams of 21 degrees Celsius water to make the final temperature of both to come out to 29 degrees Celsius? So this time, what we're going to do is we're going to find each of these variables again. We're going to look for each of our 4 variables, but we were given 2 different things. We were given gold and we were given water. So we want to know both of them. So we're going to do one for gold and one for water. That way we can keep everything separate. We need the mass, the specific heat. We need the change in temperature. We need the Q, mass, specific heat, change in temperature, and Q. All right. Do we know any of the variables? Do we know any of the 8 variables that we were given or that we're looking for? The temperature. Awesome. So let's look at the temperature. We know that our gold was originally 54 degrees Celsius. So I have it in my hand. It's 54 degrees Celsius. I put it in the water. So it went from in your hand. So let's say this is my gold. It was outside of our beaker, filled with some water. It's going in the beaker. And so did the temperature go up or did the temperature go down when we put the gold in the water? It went down. Awesome. And it went down to 29 degrees Celsius. So it made it down to 29 degrees from 54. So we were finding our change in temperature, or we're doing our final temperature minus our initial temperature. We're going to do our 29 degrees Celsius minus our 54 degrees Celsius to find our change in temperature. So what should my change in temperature be? We do 29 minus 54. Awesome. It's a negative 25 degrees Celsius. Because it's going to be a negative because it decreased in temperature. That's fine. Do we know the temperature of water originally? Awesome. It was 21 degrees Celsius. So before our metal got added into the beaker, it was 21. And then once our gold was added to the beaker, it moved up to 29. So when we do our final temperature minus our initial temperature, we're going to do 29 degrees Celsius for the final temperature now, minus the initial temperature of 21 degrees Celsius, which means our change in temperature here is what value? Awesome. It's 8 degrees Celsius. Awesome, awesome, awesome. Okay, so we have our temperatures. Do we know any other information? Do we know M's? Do we know C's? Do we know Q's? Do we have anything else? We have the mass. Okay, what mass do we know? Do we know the mass of gold or the mass of water? Is this 468 grams? Is that gold's mass or is that water's mass? Water. Awesome. So we know this is 468 grams. What else do we know? Do we know specific heats? Do we know the mass of gold? Do we know the Q? We know the specific heat, and we know both of them because they're right over here. So we know water specific heat in liquid form is always going to be 4.184 joules per gram degrees Celsius. We know the specific heat of gold is going to be 0.129 joules per gram degrees Celsius. All right. Do we know anything else? Because right now this leaves us with 3 missing variables. So that's not great because that's 3 things we have to find. Let's start by looking just at water because water only has 1 missing variable. So when we set up our Q equals MC delta T, we have our M, we have our C, we have our delta T. So Q equals 468 grams times 4.184 joules per gram degrees Celsius times our 8 degrees Celsius. All right. We should be able to multiply all 3 of those together to get a Q value. And what Q value do we get? Awesome. 15,664 joules. And we're not going to worry about sig figs yet because we're not done. All right, so we have everything on our water side. So we have everything over here done, but we're still missing 2 variables on our gold side. Okay, this is where things get a little bit trickier to remember, is that when we place the gold in the water. The amount of energy that water gains. So water is gaining this much energy or this much heat. Okay. The gold has to lose that same amount. So gold is going to have a negative Q that's equal to the positive Q for water. So these two guys are going to be equal and opposite. So they're going to be the same value. One of them's just positive, one of it is negative. And the negative one's always the one that lost energy or lost temperature. So that when their temperature is decreasing, they're going to have a negative Q, which means that their Q here will be that negative Q. So what we can do is plug negative 15,664 joules in for our Q, and that becomes a new variable we know, which means all we need now is our mass, and that's what we're looking for. So now we replug in our equation, Q equals mc delta T, and we're going to plug in everything we know. So 15,664 joules equals m, because we don't know it, times the 0.129 joules per gram degrees Celsius times the negative 25 degrees Celsius. And we can solve for m. Again, m value, let me know what you get. Anybody get an m value yet? Anybody else get 50,516? I want to say be careful on this one, because when we're doing this, all right, we're going to multiply these guys together first. So we'll have negative 15,664 joules equals the mass. And when we multiply our 0.129 times negative 25, we're going to get negative 3.225. And that'll be joules per gram at this point. And then when we divide both sides by the negative 3.225 joules per gram, these guys will cancel, and we're going to be left with mass not being 50,000, but it's going to be 4,857 grams, or rounded to significant figures, 4,860 grams. Does anybody have any questions on either of those things? All right. Then the only other thing you guys have for today is your review, your unit review, okay, for your summative. Your summative will be open tomorrow through Sunday night. So it'll be open tomorrow morning through Sunday night. If you have any questions while you're working on your summative, I am available even though our class does not meet on Friday. Please send me messages or we can meet one-on-one through Zoom if you need to during the day to go over anything for that summative. All right. Going through this, there are just a couple things I do want to remind you guys as you're going, okay? Right here, when you're doing your exothermic or your endothermic, remember that endothermic energy is being gained by the system. So our delta H, our enthalpy, is going to be positive. If enthalpy is negative or delta H is negative, we have an exothermic reaction. And so a reminder that endothermic, we would add delta H to this side. If it was endothermic, if it was exothermic, delta H would get added to the product side because it's also being released. So just a reminder on that. Not saying that's happening on either of those, just to give you that heads up. Then down here, there are just a couple of things I just want to reiterate. Units, kilojoules and joules do not match. Make sure your units are matching. The other thing, when your specific or your enthalpy value, or sorry, this is your entropy value. When your entropy value gives you joules per mole Kelvin, but the problem asks for degrees Celsius, remember that Kelvin is equal to degrees Celsius plus 273. So make sure you remember that because you do need to convert, making sure all our units match up. So if we have kilojoules and we have joules, we need to make sure either they're both kilojoules or they're both joules. The other issue that I was seeing, last but not least, way down here in your entropy values, guys. So this one, I'm going to say skip this section right here. Okay, you don't need to do the multiple choice section because yes, it might look like it shows up, but really you're going to have to do a little bit more work to find the actual answer. So just go ahead and skip this all together for these three. Just solve those entropy values just like you were. Okay, skip the fact that there's multiple choice on those three problems because it's not going to be as beneficial as you would, as I hoped it would be. So we're going to skip over those three. And then that is all I have for you. If you guys have any questions, please let me know. The answer key to this and your formatives are all on Canvas. I am going to put videos tomorrow morning. There will be 3 videos on Canvas, one going through each of the 3 formatives that we took. If you have any questions on anything, please let me know. Otherwise, have a good rest of your day, and I'll see you guys on